We're now going to do another example of finding the derivative using the difference quotient. So this says find the equation for the tangent to f of x equals x over x minus 2 at 3, 3. Then sketch the curve and the tangent together. Okay? So to find, what we're really looking for here is f prime of 3, and we'll use that to find the equation of the tangent line. But this will be the slope. Remember, this is equal to the limit as h goes to 0, and it will be f of 3 plus h minus f of 3 all over h. So plugging that in, we want the limit as h goes to 0. We're going to plug in 3 plus h, so we'll have 3 plus h over 3 plus h minus 2 minus, when we plug in 3, we just get 3 all over h. Let's clean this up a little bit. So in our fraction, we can do 3 plus h over 1 plus h, 3 minus 2 minus 3 all over h. Now to combine our numerator, we need to make a common denominator. So we're going to have to multiply 3 by 1 plus h over 1 plus h. So we're going to have 3 plus h, and then if we distribute this, we'll have minus 3 minus h all over 1 plus h all over h. Here you'll see the 3's cancel out, and oh, this should be minus 3h, right, when we distribute. So when we simplify, the 3's cancel out, and we're going to have minus 2h over 1 plus h all over h. Now remember, when you're dividing by a fraction, this is like dividing by h over 1, you multiply by the reciprocal. So we have negative 2h over 1 plus h, and we're going to multiply by the reciprocal of h over 1, which will be 1 over h. Now those h's cancel out, and we have the limit as h goes to 0 of negative 2 over 1 plus h, and when we plug in 0 for h, we get negative 2 over 1, which is just negative 2. So our slope for our tangent line is negative 2. Now, to find the equation of the tangent line, we're going to use the slope of negative 2, and we know it intersects at the point 3, 3. So we'll have y minus 3 equals negative 2 times x minus 3. And when we distribute, we get y minus 3 equals negative 2x plus 6. And we'll add 3 to both sides, so we'll have y equals negative 2x plus 9. So we'll graph that in a minute. Now remember, so that was our equation of our tangent line. The original directions asked us to sketch the curve and the tangent. So we want to sketch x over x minus 2. Well, a few things we know about that graph. We know it has a vertical asymptote at 2. It's got a horizontal asymptote at 1. We know 3, 3 is a point on the graph. And so it's going to look like this. We know 0 is a point. You can check on your calculator, but the graph looks something like that. And if we want to graph our point negative 2x plus 9, our tangent line, unfortunately, 9 is a little off our graph, but then we would have these points. And you can see that that line is in fact the line that's tangent to our curve at that point. Okay, so this is just to show you that our process of finding that slope and finding that line, and then that if we graph that line and the original curve, we see that that line is indeed the line that's tangent, just touches the graph at that point.